So we're not going to keep you waiting long, so anybody who's going to come is going to attend. Also, I'm not going to take much of your time. Thank you all for coming. This is an amazing group. I didn't expect that we're going to get this number. And it shows how the big interest that we have in AI and machine learning. So this group has been formed. I'm representing my friend Tariq Al-Jaber, who organized this group and the meetup. He's in Amman, Jordan. Currently founded a new company called Basit. So I would like to thank Basit for having us here. Of course, his co-founder Baha is here as well, so you could speak with him. I think this is gonna be a very interesting session, especially with the guys who are gonna be speaking. I'm gonna let them introduce themselves, but for us, AI and machine learning are becoming an essential part of the engineering and data science and everyday workflow. ML teams need new tools and data versioning, so that's really important. You have these tools. We're going to know more about that. And of course, we're looking forward for the QA session after we finish. We'd love to hear more from you, whether it was on the speakers themselves and even things that we could improve as a group. Would love to expand more. I think we're on the verge of something really big. My name is, of course, Mohanad Taslak. They call me Mo Taslak. I'm a CEO of a company called The Next Dimensions. We're a 3D printing technology company, and we're moving also to adopt machine learning and AI in our work. And I would love to hear more about what's happening here. Thank you so much for coming. Thank you.
Hi everyone, my name is Sveta. I'm driving the community at dvc.org. Today we have two wonderful speakers. One of them is Dmitry Petrov, the creator of DVC. The second one is Dan Fischetti, the head of research at Standard Cognition. So let's jump into Dmitry's talk, and today he's going to talk about open source tools to version datasets and models. And welcome, Dmitry.
Hello, everyone. Today I'm going to talk about open source tool for versioning machine learning models for managing ML experiments. I'm one of the creators of project DVC, dvc.org, one of the open source tools. So my opinion might be biased a little bit, but I'll try to cover this up from different angles, and I will cover a few open source tools. As you can see from my short bio, I was constantly moving from the north to the south. Actually, I was born and raised in Russia, in Siberia, and then I moved to a warmer place inside Russia, and then to sunny Seattle, and I joined Microsoft. And recently I relocated to San Francisco, so I finally saw the sun. All this like finger on the top. And I don't know, I'm wondering what is the next. Maybe, I don't know, India. So at Microsoft, I was data scientist at Gink, and I have seen how large companies organize workflow, how they make data science team be productive, and what kinds of best practices they use. And this has partially motivated us to create the project. We'd like to bring these practices to the open source stack, to the open source tool set. So first of all, we need to understand what's special about it. Why do we need new practices? Why do we need new tool stack? Or maybe we don't need it. We don't need this. And then we will cover the open source tools. Like one of those would be MLflow, GitLFS, which can help with our projects as well, and our tool DVC. So let's talk about machine learning. There is a common opinion that we are not very productive when we are doing a real project, when we are building AI project. We have a lot of time for simple thing that we like versioning data, moving data, doing the same, we are doing the same things, the same thing over and over again. And there is an opinion that we need to reinvent the workflow, establish these best practices, and reinvent the entire tool set in order to be more efficient. So let's think what is the difference between the software projects and ML projects. And one of the first and straightforward difference is how we do hyperparameter tuning in ML projects. This is probably problem that everyone knows. This is the problem when we try to find the best combination of our parameters when we do small modifications in our config files, in our code, in order to find the best model. Why this is special? When you're on the hyperparameter tuning stage, the dynamic of your project is completely different compared to software engineering. In 1 hour, you can run dozens, sometimes hundreds of different experiments, and this is not something that you do in software engineering. You probably don't wanna track all these changes in your Git software, right, or in your versioning software, but you still need to know what parameters you have tried and what result you get. And people usually use this technology, which is called Excel spreadsheet, in order to track these parameters, in order to kind of keep history of your experiments. The next difference is, to understand what is the best model, to understand what is the best experiments, you need to use some metrics or combination of the metrics, right? And this is how we navigate through our experiment. This information also needs to be tracked and stored somewhere. And some ad hoc tools usually is in use, like this one. So you need to keep models. You need to save the models because you probably don't want to rebuild the same models over and over again. You don't want to waste time on those. This information also needs to be stored somewhere. I'm using this analogy with an Excel spreadsheet, but like many companies have a variety of conventions and tools to do this. The next difference is data sets. We have to deal with dozens of gigabytes, sometimes hundreds of gigabytes of data. And it takes a lot of time to move the data between your storages like S3, between your laptop, between your cloud instances, and the same with derivative data sets like process data, models, and so far and so on. It's quite a painful and slow process, and it becomes even more complicated when data evolves. When you're having like labels like every single week, and you it basically explodes amount of your data for experiments and models. So this information needs to be preserved somewhere, of course. And the last difference, which is actually not a difference, it's similar. We still coding, right? We still write code for modeling. We use like some frameworks. We still commit our result somewhere. But this information, our code, is not connected to the ad hoc conventions, to the Excel spreadsheets that we have had before. So this information needs to be also connected somehow, or you can put this information to the same place. So quite a lot of difference, and all these conventions and spreadsheets, it's probably not the best solution. As an engineers, we have learned if you do something manually, it means something is broken in your code, or something is broken in your process and needs to be improved. How you can improve this? You should automate the stuff. And this is a usual solution. So let's take a look at the tools which can help you automate this process, which can help you to collect this information, preserve this information in a more systematic way. The first project is MLflow. It's a project from Databricks company. And one of the biggest value it provides is its hyperparameter tuning. With MLflow, you can run dozens of experiments, and it can capture your hyperparameters, your metrics, your models, and put it in some place like directories, or you can think about this as a database in your machine or maybe in a cloud. So technically, it's a library. You import this library from Python or Scala, which is Spark, right, in our world. And then you instrument your code by some statements. This is my hyperparameter. This is the value. This is my another hyperparameter with the value. This is metric. This is model name. And when you run the code, it generates all this information and put it into this database. When you run UI, you can see something like this. So your table, it's more or less the same table, the same spreadsheet that we had before. But it was created by software, and it's much more complicated to introduce some mistakes in here. So MLflow does a good job on hyperparameter tuning stage when you do hyperparameter tuning. But when you jump back to coding to change your model, change your frameworks or data processing algorithms, you need to version your code. And this code can be also put as an input to the framework, but you need to do this manually, which means the connection is kind of broken. And this is not the best framework when you deal with data sets, with a large data set. I'm talking about gigabytes, dozens of gigabytes, etc. Because all the data it captures needs to go to this central repository, central water database. You probably don't want to do copy each time you run a copy of 10 GB when you run your experiments. To solve the problem of capturing data and code together, you can use GitLFS, which stands for Large File Storage. This project has a lot of similarities with regular Git experience. It's a command line tool. It extends Git by large files. So you can put, now you can put megabytes, hundreds of megabytes, sometimes even gigabytes to your repository with this tool, with the same Git experience. So it's quite a simple tool. I'm not saying that Git's simple, right? I'm saying that if you have experience with Git, you will be able to, you will figure out how to use LFS. However, you might have some issues when you work with a large data set. The tool was developed not for data projects. The tool was developed for front-end engineers, for engineering scenarios. And large data files in GitLFS means like Photoshop file, like a few hundreds of megabytes. It means image file, like 10 megabytes, 20 megabytes. It's not about like 5 GB data sets, 50 GB data sets. So you will hit this limit sooner or later in your ML project. And this project does not have support for machine learning specific scenario. Like if you version your data files, how you can find commit when the model has the best metrics, for example. So nothing like this exists on this GitLFS world, unfortunately. So not ML specific, but it can connect data and code. probably not data, but models, which is still data, right? Like models is like dozens of megabytes, hundreds of megabytes, but not even gigabytes. When I work at academia, I actually, like about 10 years ago, I didn't need any tools at all because I was working usually alone, maybe with like 1, 2 guys in a room, and we were able to manage everything with a pen and pencil. It was enough to track an experiment. But when I worked at Microsoft, I was really surprised how they organize the work. What kinds of system, AI platforms, they have built in order to make their data scientists efficient, in order to make the teams of data science efficient. So when you work inside platforms, you don't care about all this like simple, all this infrastructure questions. How can I allocate machine to run my models? How to move data to this machine? How can I get results from my previous experiment from the last month, for example? Those problems just don't exist because the platform solves this infrastructure and data management, data versioning problems. However, when I moved from a large company and joined a startup, I was really surprised how they work without those platforms. Now, in a startup, you need to do all the stuff manually. You need a machine, go and create an instance. You need to train model first, copy data, then train it, then move your model somewhere back. Then you will realize, all right, it was some wrong version of data set, I need to do this again. Or tomorrow you will say, all right, I see the model, but what data set I use to train this model, right? So, and you end up wasting a lot of your time, hours, sometimes days, to those simple questions and problems. And I ask teammates, we are wasting a lot of time, but can we find some solution, why we are doing this? And everyone was saying, you know what? This is how machine learning works. And this is our kind of a best practices today. And you can figure that out. It's not a big deal. I was saying yes, it's not a big deal, but I don't want to waste this time. I don't want to waste my time with my teammates. And I know that there is a better approach because I've worked with AI platforms when all these infrastructure problems are solved. And I was surprised why this is not solved in open source stack, in existing technologies. And this was the motivation behind the DVC project. We need to solve these basic problems, resource allocation, data versioning, data movement, and experiment management on top of open source stack. And data versioning is the core piece because it's connected to each of those areas. We should be able to manage large data sets. When I'm saying about large data sets, it means any amount of data that's supposed to be processed in a single box, in a single machine. We are talking about gigabytes, dozens of gigabytes, hundreds of gigabytes. It should support storage that we like and use, right? Like S3, Google Clouds, or just SSH storage that you have in your office. I believe these solutions should be part of the existing software engineering ecosystem, existing software engineering stack. We don't want to reinvent Git. It should be somehow, it should work and connect with existing versioning systems and utilize some of the best practices and introduce new ones. And of course, it needs to be ML, it needs to support ML specific scenarios, right? Like navigation through metrics, creating ML pipelines, which means connection of your data and model with the code which present. So we have created this DVC project, which stands for Data Version Control. It provides very simple command line experience, similar to Git, but with additional DVC commands. It does different things. Versioning data, pipelines, metrics. I will show you a very simple example how you can version data in your repository, just to make you feel this experience. So first of all, it works on top of Git repository. So let's create some Git repository, empty Git repository. It will be, I don't know, binary classifier, for example. So now it is a Git repository. Let's make it DVC repository now. Some meta files were created in this repository. Now we can add data here. I will be using relatively small file, like 36 megabytes, but it can be like 36 gigabytes. It can be directly with 100 GB with like millions of images. To add this file into your repository, you just run DVC add commands. Quite similar to like git add, right? But it's a DVC add. All right, it's in here. Now we need to set up our storage. So you can work with S3 or any other storage that you prefer. So let's set up this. And DVC has a special concept of data remotes. In a Git, you're probably familiar with the concept of remote, right? Your remote is basically your Git server. Within DVC, we introduce the concept of data remote, which is like S3 bucket or SSH server or Azure directory. So let's do this. DVC remote. It is going to be default remote, like my S3, for example. And what was the name? Let me check. Yeah. Demo. All right. No. All right. Sure. We need to add the remote. Right? Here you go. This is how it looks like in a concept level. So your Git server is a code remote, and our S3 bucket, in this case, our data remote. We commit our code, our meta files into Git, as usual, and data goes to the data remote. So let's push data. So you see, we just copying data to the remote bucket. Let's wait a minute. All right. So how it works under the hood? DVC creates additional meta files, which we call DVC files. And you can think about DVC files as a pointers. We have a pointer, first we have a pointer to our S3 bucket. And for each data file, for each data, we have a pointers inside the bucket. Let's take a look at how it looks like. So DVC configuration file contains information about our data remote, right? Pointer to the remote. And DVC file has all these hash sums, which is a pointer inside the remote, and the path to the data. So it basically says, if you'd like to extract this piece of information, you need to name it data in my workspace here. So all this information needs to be added into your Git repository. This is the amount of files we created. It's a config file, it's a DVC file, and we created a couple of DVC ignore files because we don't want to push our data files, right, into Git. So let's DVC put them into Git ignore automatically. So now we need to push. Oh no, we need to commit first. And we need to push, but push probably won't work, right? Because code remote is not set up yet. Let's create a repository and push information here. So, oh, daemon for some reason. I expected demo, but it's like, all right. So, all right. Meta information in the repository, right here, right? So no data is here, only meta information. And now let's imagine that we have created this repository, and we need to transfer this project, this data version to your teammates, for example. Or in some cases, you need to clone this information and they, as well as data, to your EC2 instance when you do some training, for example. And it looks like a usual Git experience. Git clone, and you got all the meta information here, right? With all the pointers to the store as well as inside the store. Now let's do pull, which copies all the information inside your workspace. And now, if we modify something here, if we modify data, if we add more information, if we add more data and push everything, the next colleagues will see, the next teammates will see all the changes. So, very simple example with how we can version your data, but DVC has a lot more capabilities. Unfortunately, we don't have time to show all the stuff, so we can discuss this later, or you can go through our get started, but I will mention some of those. One is a pipeline. Concept of pipelines basically connects your store data files with model files, or data files with process files, with model file with metrics file, for example, right? It can be like complicated. With these pipelines, you will have the same ability to put this pipeline information into Git repository. And your pipeline with data will have like a snapshot inside your repository. And now you can navigate through your versions of data files, versions of your pipelines as a snapshot in a Git storage. We have metrics, metric file, which can help you to navigate in the repository. For example, you might have a few branches, and the question would be in which branch the metrics has the best value. In which this combination of the metrics have the best value. It's a separate set of DVC-specific commits. So we replace this concept of experiments and data versions by Git commits. And now you can jump back and forth between versions of your data, between versions of your experiments. And the entire team can use this technique to navigate through your ML projects. You can imagine that this is how we are replacing. This is how we incorporated. This is how we replacing these conversions Excel spreadsheets with Git history. And this is one of the best engineering practices that like engineers created during the last like 20, 30 years. Replace everything with Git history and Git commands. You can imagine that this technique might not work in a hyperparameter tuning stage. When you'd like to have, let's say, 20 of experiments or maybe 100 of experiments, you probably don't want to have like 100 branches. you probably don't want to have like sequence for 100 commits with small changes between those, right? So this is something that DVC needs to, then we need to implement in DVC, and we are working on this. But from data management point of view, code and models, it can give you a pretty good experience in your ML projects, and metrics will help you navigate through the experiments. So let's take a look how in which cases this tool can be used. So usually the breakpoint is data evaluation versus hyperparameter tuning. If you tune parameter and spend a lot of time on this, you probably need a lightweight concept of experiments, and ML flow might be a benefit of this. And DVC works better when you have large data sets which are evolving. And DVC can do all this heavy lifting for you. But the thing is, those tools are not mutually exclusive. And today you may find a lot of blog posts from different people how to use those tools together. Because DVC works well with data, and when you write code, once you jump to hyperparameter tuning, you can switch to ML flow functionality and work on the hyperparameter tuning, and then return back to coding and improving your data sets. And GitLFS can be kind of a compromise, like very simple experience, which can help you to manage your models with a relatively small overhead on top. So some teams use LFS for at least for model version or dataset version if it's the dataset are small. So today we see a big move from software to data projects, and the entire tool set to be reinvented. The last similar change happened like 30 years ago when we moved from hardware design to software engineering. And the question is like, do we need to wait 30 years to be more efficient? And the big question is how to make it faster, how to be productive, how to become productive as an industry, as a teams in the near future. And I believe we need to do a few things. First, we need to analyze deeper the process. When we waste our time, when we make the mistake, and we need to try to automate this by new tools. We need to try new tools, or maybe even develop new tools, because area is new and a lot of problems are not solved in this area. What is even more important, we need to share this knowledge, share the knowledge about successes and failures with the tools, when it works, when it doesn't work, why it doesn't work, and so far and so on. So we need to go and speak and talk about this experience. And I believe that open source is the only way to make this transition efficient, this transition fast. This is the best way to share knowledge. This is the best way to make this transition. So we need to use open source tool. We need to contribute to open source project, and the transition will happen faster. So thank you very much. Now I'm open for questions.
Yeah.
Sure, go ahead.
What happens when you have a data set that you can't meaningfully store on your laptop? So, database connection or some large Spark data set or whatever?
Yeah, so it depends on what are you doing with the data set. If your goal is to create some model, then sooner or later you will leave your data set. You will leave your database, right? And you will put your data set to some machine, which is going to run training. Right? Usually, the training happens on a single box in using like TensorFlow or some like PyTorch frameworks. It's not happens inside database, right? So on some step you have to leave databases. And this is the place when DVC starts working. A lot of people, a lot of teams use DVC specifically for this scenario. When we run some query in a database, or when we run some Spark job and we got a dump of data, then we need to do machine learning. But first, how can we preserve this information to make sure our model is kind of consistent with the data we use? Before, if you run the same query again against the database, you'll get a different result, right?
Yeah.
So yeah, this is when DVC start to work in the database world.
Okay.
Actually, two questions. First one, when you make an update to a data set, do you copy whole plot or you just count somehow difference you compute it?
Good question. So we don't compute difference on the file level. We do compute difference on the directory level, which means if you update 20 GB data set to another 20 GB data set file, right, you will get two copy of the file. However, if you have 20 GB of images and you added like 1,000 more images, right, we will add 1,000 more images and one without creating additional copy of the existing ones.
Kind of assume that the users kind of provide sharding. So there is an assume that shard will change won't affect a lot of shards.
What do you mean by shards?
I mean, just split some data set and you assume that you have some update and would affect a lot of pieces of it and different plans.
I think yes, if you assume that shards is kind of your single file, then yes. Yeah.
And now questions about, do you care about data replication here? Like if you're not sure about it, your host will be available for some reason and you operate data?
Yes. So in the tool, no. However, usually people assume that your cloud storage, your S3 bucket, your SSH server, it's a kind of a golden data set, if you wish. And I understand, yes, your concern, but this is a usual assumption. Or you can create a new copy of your data remote, right? You have one data remote. You can easily clone this and then set up another data remote and push this again. So you will have like two shards. It's the same like a Git, right? How many shards you need for a Git, right? It depends. Sometimes one is enough because your team is distributed. Each one has own copy. Sometimes you will create like two.
I mean, for source code, you have a copy of the code that each user runs the data set. You mainly assume that you have some data set as well. Main storage. Okay.
More questions? Go ahead.
We have some fancy UI, like maybe GitHub for Git, but DVC catalog for DVC.
Well. No, not today, unfortunately. So it's kind of a common experience today.
Like, wasn't there a project to build something on top of DVC GitHub stack?
Oh, you are right. Okay, right. There are a few projects which are kind of UI on top of DVC. One is duxhub.com. Then there are a few projects are thinking about integrating DVC inside. So you might have like a few. Today's answer is kind of maybe 1, 2, but not very popular. But then there are a few teams are working on some UI capabilities on top of this. We will have more.
Question. So you at the beginning when you added the XML file to DVC, there was a progress bar,
right?
But it was not uploading it to the cloud. What was happening with this progress bar? What was happening when it was showing the progress bar?
It was about cooking, right? It's about downloading and uploading first.
And uploading. Okay.
Yeah. So that's it.
Thank you.
Hi everyone. So I want to talk today about how we use DVC at Standard Cognition to manage our cascade of models. So first, to start, what is Standard Cognition? What do we do? So our solution for autonomous checkout And what that is the capability to walk into a store, take whatever you want off the shelf, walk out, and then get charged without having to wait in line or skip cashier, and just skip the line entirely. The way our system works is purely computer vision, camera-based system. There are no sensors in the shelves. The problem we need to solve is, given a stream of a collection of camera streams, how to determine who is who in the store, who has what, and also when are people's cards cheap, so we can compute a history of people who took and put back on the shelf. When you leave, we can give you your final correct receipt. But how does it work? Very often when we interview new candidates, one of the first questions we ask them is, how would you build this system? Generally, people converge onto a pretty good solution in about 45 minutes. One that I think illustrates a lot of points and is close enough to spirit to the way we really do things that it's a good illustration without giving too much away. So the first thing people usually arrive at is person detection. So you need some way, given a image from a camera in a store, to figure out who the people are and where they are in that camera. So once you've localized the people, the next stage people usually come up with is item detection. So if there are two people in the store, what are they holding in their hands, and what are they holding anything? And if they are, what is the product? So that's sort of a convolutional neural network is a way to implement that. The person detection is also a CNN. And then the last stage here is figuring out what are the changes to these cards. So this is closest to an action recognition problem. It's not fully clear how to determine if someone is taking or putting something. So the way to get this to work is you take a sequence of these item detections over time, and it's based on the frame. You can figure out, okay, this person is taking yourself, push here it goes, and then given enough samples over time, you can now build up a cart for a person. So very quickly, we have invented sort of a cascade of models where the output of one model feeds directly into the input of a second model. So the first stage here, again, summarized, is a deep CNN to detect people. Now conditioned on the first detections, we run an item detector, and that is trained on the output of the previous model. So we take crops of people from our person detector and some labels for items, and we use that trained item detector. And then the final phase is a sequence model, which can be an LSTM, some kind of any sort of sequence model here. You can use that to predict the actions based on your first item detections over time. So what are some issues with this cascade? Well, we should look at some of these input-output relationships to kind of figure out what this looks like in practice. So here you have some crop person, and we train on a bunch of these crops to figure out, what are they holding in their hands. So we have a second here, which is predicting this guy over here is the holding shirt right now. So what happens now if we want to retrain our person detector? We decide we have a better model, we detect crops, we feed this into our existing item detector. What happens? Generally, you can actually expect this to work pretty well. You can see there's some next variances, and you don't need to worry too much about the exact size of the crop. They're mostly translation and variance here. So now the next phase is you have your item detections. Take a sequence of those, feed them into your action recognition model. So one way you can do this is to take your bounding boxes and the probabilities over your predicted classes over time, take some sequence of those, and feed them into, let's say, an LSTM. So if you do that, your input might look something like this. The first four numbers are your bounding box coordinates. The last three are your possibilities over your classes. Let's say you decide now that actually you get better accuracy. You feed in the raw logics here and not the softmax. Softmax actually squashing the information into not super easy space to start doing some inference on. So your number something more like this. The problem comes about when you have a better item detector. You retrain a new model. Now your inputs to your action recognition model look something like this. So between these two examples, the last couple numbers are in a totally different space. But as you take the softmax of them, the probabilities work out to basically the same thing. So it's really constrained on the output of a neural network as to like what space it looks like. You're just trying to get to optimize the full probability classification loss here. So if you try and pass this in to a model that's trained on outputs that look like this, you're going to have a bad time. So fundamentally, we need to be able to answer this question. How do we make sure each model is trained on outputs of the correct model that's trained? So we should start really thinking about this problem. We can visualize what this dependency graph looks like. Anyone familiar with machine learning here probably will notice an issue where we are training and inferring on the same input for distinct space. I'm going to collapse these down, but try to illustrate here that there's a set of videos that we train this model on. There's a set of videos that we run the model on to save these outputs. So we look at the next states here. We take our person detection outputs, we train an item detector with these, now save these outputs into another feature space. And finally, we train an action recognition model on these detector features, save the actions out. This is only 2 videos right now, so it's sort of a manageable graph. Very quickly, you can start adding a lot of complexity to this. So let's say now you are deploying the system in 2 different stores, and they have different sets of products. So you want 2 different item detectors. You have a store A item detector, store B item detector. You want your first detector, your action recognition model to be general across stores, and you want your item classifier to be specific. So looking at this, it's already fairly messy. We only have 3 videos so far. So we decided to need some kind of system to answer this question. What model generated what data? So what does your workflow look like if you have no system and you want to manually keep this all in your head? So let's say you want to train an item classifier, an action classification model. You take your item classifier, run it over some videos. So you get 2 stores, you run the script twice, save all your outputs, train your action classifier, and now you have classifier that you can run on those 2 stores. Let's say another developer comes along and they retrain the store A model. Now, what he needs to do to have a consistent set of data models, you need to rerun the detector over the 2 videos of that store, and now retrain your action classifier over all 3 videos. Maybe if you're one person working in this kind of system, you can manage this yourself, but once you are on a team with 2 or more people, this handoff process gets really messy, very hard to scale. So we decided we needed some kind of tool to be able to manage this entire system. So we started with DBC, and that was a good choice for a lot of reasons. So for one, it's really good at data versioning, being able to share data, collaborate, update models, figure out what's the exact version of everything. You get a nice Git commit, which maps the entire state of your models and data. That's all great. There is some system for dependency tracking, which was touched on briefly. So if you specify, say, DBC run, specify your inputs and outputs, and now your output is tagged with the version of your inputs. That actually will solve this problem for us, where we want to say what model is used to generate what output. So what does this look like in practice? In the DBC run command, you specify all your dependencies and all your outputs, and then run your script inside this command. So this definitely works, but if you want to now turn this into an entire workflow, you have 2 options here. You can always run the command this way with the DBC run mechanism. You have to know explicitly what are the inputs and outputs for all of your commands. DBC also does provide a DBC repro command, which will kind of reproduce your entire pipeline. But it does currently assume that your inputs and outputs are the same. So if you're adding or removing data, or if you want to kind of distribute this work across machines, a little bit difficult with this sort of pattern here. So if you want to make extra changes, you're back to DBC run now, and it's very likely that a developer can potentially miss including a dependency or add an additional output that's not capturing the right structure. So kind of figure out what the inputs and outputs of this pipeline is. So whereas the DBC model requires you to specify your inputs and output on script level, it builds a library on top of DBC which lets you specify the file types of all your outputs at the function level. So not what file is produced by this script, but what type of file is this function created. It's also a mechanism to specify what is the relationship, the input-output relationship between your data types, which can be models, and output data. That all lives in Python code. in one single place. So any developer can look through, okay, here's the dependency graph in code, and I can read this and use it to build more functionality. So whereas the DVC method for running a script like this, it's a kind of big long string here. We want to be able to do something simpler like this. Just run Python item detector.py, and everything internally should be category. How do things work? There's three components in the library that we built. There's templates for file paths, so being able to specify not just files, patterns that files all fall under. System for specifying dependencies between these file types, and then function decorators. So this is a Python library letting you annotate your code, specifying exactly what kind of inputs and outputs go into each function. So let's look at a couple examples to see what this looks like in practice against Python. So this first line here, we are expressing that all videos are going to follow this same structure relative to some DVC directory. So you have story name, video name, and then video.mp4. Similarly, we can say that these first features that we created have a similar name structure: story name, video name, and then person crops. DB is some LMDP or some file that's storing for outputs for this person detector model. Similarly, the item detector model has a store parameter. So if you're familiar with Python format strings, these curly brackets may look familiar to you. What this is saying that these are the properties that can change and take on many values. So we have many different videos, many different stores taking all of the different names. So now that we find these types, what can you do with them? You can start specifying dependencies between types. So when we say our item detection model depends on the set of person features, we are expressing the idea, which is implicit to a user, that we take many of these person features and use it to train one single item detection model first. And based on the way the parameters are, so different matches, that'll figure out the exact set of files. So if you want to train an item detection model for store A, implicit in this relationship between these two file templates, you're saying that you take all the videos from store A. Video name is unmatched, so that can take any value. So you take many video crops and use them to train one single model per store. Similarly, you can say our item detection features depend on the model and on person features. You can see here, store and video name matched exactly. So there's one person features per item features, and there's one model that's used to create many different type of features. So now that we have these, we've essentially created nodes and edges of a dependency graph. What can we do with it? So we can start decorating our code, and you get some nice properties out of this. So we provide a produces decorator, let you say, what kind of file is this function going to create? So your train loop, you can write as you otherwise would, just decorate it at the top. What this will do for you is it will ensure that anytime you train one, it's tagged with all the person props files that went into that model for that store. So the exact training set, the checksums of every individual piece of data that went into that training loop is now captured in your DVC metadata. Similarly, you can decorate your inference code to say, when I run this item detection model, I want to tag the model that was used to generate this data and the features that the model was run over. So now you've decorated code, your actual scripting logic can be super straightforward. So all we're doing here is we're looping over stores in some collection of stores, and then for each video on that store, first the training model, and then for each video on the store, we're running the over all the videos. And that this loop is now doesn't really, from a developer standpoint, you don't need to do anything special once you've decorated your code. This will now make sure it's tracked properly. All the inputs and outputs are going to be tracked automatically in the DVC metadata for each of these outputs. So the data and model will be tagged automatically. So what's missing here is some kind of control. So what's the difficult part with the way it's written right now is anytime you want to run a script, you have to train every model and run over every single piece of data. Model training is slow, running models is slow, it's expensive, compute and time. Generally, to avoid it, we want to skip steps that we know we don't need to rerun. So we provide an allow rerun option for these decorators. What this is saying is since we know the exact inputs and outputs for these functions, if I already have an output for this function and its dependencies have not changed since last time, I just go ahead and skip this step. So now as a user, you don't need to really know anything about what state any of your data has been in. Automatically, based on the DVC metadata, it'll determine this function needs to get run for this argument, not for this argument. And your workflow is now much simpler. You can continue to run the same exact set of scripts, does not take any sort of arguments, and anytime you want to arrive at a consistent set of data and models, your workflow is super straightforward, very hard to mess up, and everything is tracked automatically. So when a user decides they want to tweak a pose model or an item detector, they just run the same set of scripts every time. Now everything should be consistent, and you can take all your models and deploy them without worrying about sort of data consistencies. So what's next? We are working with the DVC team. We want to try and open source this. We're working to figure out what parts of this are here, very specific to our problem. I think a lot of this will be useful for the data science community in general. And also, we want to start working on how do we take this out of just Python land and figure out how much of this pattern is useful elsewhere in data science. The ecosystem is much larger than just Python. So we definitely want to be able to take this and use it in as many places as possible. So with that, I'm going to say thank you. And if anyone is interested in building out best practices for machine learning at scale, we are hiring. So if you want to check out our website or LinkedIn, any other questions, come find me after the talk. Happy to talk about it. Thank you. We want to do any questions now? I can take a few questions after. All right. Yeah.
So the first question is, how do you guys have time for doing open source methods?
It's a good question. So right now the process is wrote this library internally. Most of it is pretty generic, and I just kind of took a zip file of it and sent it to these guys. That's the state of it right now. Hopefully we'll find a little bit more time in the future to kind of iron out the kinks and make it generic. So it's a work in progress. It's not available right now.
Second question, but I noticed that your data sets have some DB format. So how do you store your data about the, protection data?
Yeah, so a lot of this is a little bit locked for presentation purposes. That DB is sort of a made-up extension. There's a lot of different researchers working on different pieces, and there's not one consistent data format. It is something we're working on. Some things are JSON files, some things are like LMDB, which is network map database. And we're trying to consolidate this, but we're also building a super flexible system to allow you to make these ad hoc JSONs or flat buffers or any sort of system that lives in a file structure should be captured by the system, which is kind of the DVC model. Anything that's in a file will be tracked.
Then one last question. So if you add some extra data to the somewhere in the middle, like your own, would it continue to run? Like does it break somewhere or?
So if you add more files of the same type, it should work pretty seamlessly. You want to add a new file type somewhere in between. It is up to you to, when you update your data, you also update your dependency graph to reflect that I have some intermediate output in between like this model and this model. Anything else? All right. Thanks again.
Thank you.
Thank you everyone for coming, for taking time. And we'll be sharing the slides and the video recording on the meetup page. So if you have any pictures or anything, just let us know. We'll want to share it as well. Thanks again. And I think we have a little announcement from our community friend.
Hi guys, my name is Alexey Krogov. I'm a fellow organizer of several meetups by Area AI, SF Scala, SF Spark, and a few others, GraphQL. So thanks, first of all, to Mo and the organizers of this meetup. We really appreciate it. It's, we have several meetups in machine learning. I just want to share that we're basically doing a conference in November called Scale by Debate. Some of you guys heard about it. It's a software engineering conference. It's the 7th year we run it. We have essentially end-to-end data pipelines for machine learning and AI approaches from software engineering background. So we have companies like Twitter, Salesforce, Google Brain is presenting. So the idea is that we have model deployment, training, and kind of best practices. So if you guys are interested, just Google Scale by the Bay. We have a code for this. I can share it if you like. And it's mid-November, November 14 and 15. And we have like serverless workshop from Google before that, how you use serverless, all this kind of stuff. So I hope it may be of interest. Just let me know if you're interested in this. I can give you more information. Thank you guys. Appreciate it.